What if everything we were told about a mysterious visitor in our solar system was incomplete? What if, while the world was focused on politics, markets, and everyday headlines, something extraordinary was quietly unfolding beyond our atmosphere? According to newly released scientific data, the object known as 3I Atlas may not be the harmless comet we were told it was. Instead, the evidence suggests something far stranger, and once you see the details hidden in the data, the entire story begins to change. For nearly a week, major space agencies around the world appeared unusually quiet. Public updates about 3I Atlas suddenly slowed down. The official message was simple: the object had already passed through the inner solar system and was leaving, fading into the darkness beyond the reach of our telescopes. It was described as nothing more than a chunk of ice and rock drifting away on a predictable path. The story sounded ordinary, almost boring. But then something unexpected happened. On January 27th, both NASA and the European Space Agency released a large batch of scientific files and images related to 3I Atlas. It wasn't a major press conference or a carefully presented announcement. Instead, it looked more like a quiet data release buried inside technical archives. The files were dense, filled with complicated measurements, diagrams, and raw observational data. At first glance, it looked like routine scientific documentation, the kind most people would never bother to read. But researchers and independent analysts did read it, and once they began studying the details, they noticed something that immediately raised questions. The key moment occurred several days earlier, on January 22nd. According to reports circulated in the scientific community, including analysis from Harvard astrophysicist Professor Avi Loeb, 3I Atlas passed through a rare cosmic alignment. For a brief period, the object moved almost directly between Earth and the Sunday. The alignment angle was measured at roughly 0.69 degrees. In astronomical terms, that level of precision is extremely unusual for a random natural object. This alignment created a perfect observation opportunity. When an object passes in front of the sun like that, sunlight shines through the surrounding dust and gas. Astronomers call this effect forward scattering. It allows telescopes to detect tiny particles and structures that would normally remain invisible. Essentially, it's like shining a powerful flashlight through a thin sheet and suddenly seeing every wrinkle and tear. Naturally, scientists pointed the Hubble Space Telescope toward the object during this moment. They expected to see a typical comet structure, a cloud of dust, maybe a few gas vents releasing vapor from the surface, but the images showed something far more complicated. The brightness of the object suddenly increased during the alignment, which is not unusual. However, the pattern of that brightness change was different from what astronomers normally see. According to the Hubble data taken with its wide-field camera, the flare revealed multiple jet-like structures emerging from the object. One of those jets formed a strong anti-tail pointing toward the Sun and Earth. That alone raised curiosity among observers. But what truly caught the attention of researchers were three additional smaller jets visible in the data. These jets appeared to be spaced apart at almost perfectly equal angles, and the number that appears repeatedly in the analysis is difficult to ignore: 120 degrees. Think about that for a moment. A circle divided into three equal parts creates three angles of exactly 120 degrees. It forms a perfect triangular symmetry, the kind engineers often use when designing stable structures. Nature rarely produces such precise geometric patterns by accident. Professor Loeb noted this symmetry carefully in his analysis. Rather than jumping to dramatic conclusions, he simply asked an important scientific question: could these three jets represent a technological signature rather than a natural venting process? It was a cautious statement, but it opened the door to a possibility that suddenly made the entire observation far more intriguing. Because if those jets were not random gas vents, then they might represent something else entirely, a controlled stabilization system adjusting the object's orientation in space. And that realization leads directly to the next discovery hidden inside the data, a discovery that begins to explain why several observations from NASA's own satellite systems suddenly went dark right when this alignment occurred. To understand why this alignment event matters so much, we need to look at what else was watching 3I Atlas at that exact moment. Hubble was not the only telescope observing the object. Another spacecraft, NASA's Transiting Exoplanet Survey Satellite, better known as TESS, was also positioned perfectly to monitor the event. TESS normally searches for distant planets by watching stars for tiny changes in brightness, but its cameras can also record other moving objects passing through its field of view. At the time of the alignment, TESS was already observing the region of space where 3I Atlas appeared. In theory, it should have captured a continuous record of everything that happened. NASA even acknowledged this observation in a short blog update released on January 27th. The post included a brief video clip showing a bright moving point against the background of stars. At first glance, it seemed to confirm that TESS had indeed recorded the object. But when researchers examined the timeline of the observations more carefully, something unusual appeared. The data contained gaps. According to the official explanation, TESS experienced a temporary interruption in observations between January 15th and January 18th due to a technical issue involving its solar panels. The spacecraft reportedly entered safe mode for a short period before returning to normal operations. These kinds of interruptions occasionally happen in space missions, so the explanation might seem reasonable. However, analysts noticed something else. Even after the spacecraft resumed operations, the sequence of frames around the critical alignment period appeared incomplete. The missing data occurred suspiciously close to the exact moment when the Hubble images revealed the unusual jet pattern. The coincidence was difficult to ignore. TESS is known as one of NASA's most reliable observational platforms. Its systems are designed to monitor stars continuously for weeks or months at a time. For it to experience interruptions precisely during the most interesting phase of the 3I Atlas event raised obvious questions among observers. Some researchers began to wonder whether the missing frames were simply a technical problem or whether something else might have interfered with the spacecraft's sensors. Meanwhile, the Hubble images continued to circulate among scientists, and the geometry of those three jets became the center of discussion. If the jets were equally spaced at 120-degree intervals, then they could represent a stabilization configuration similar to thruster systems used on spacecraft. Such a configuration allows a vehicle to maintain balance and adjust its trajectory in multiple directions. In engineering terms, three thrusters arranged at equal angles can create extremely precise control over an object's movement. By firing them in carefully timed bursts, a spacecraft can change orientation, slow down, or alter its trajectory. This possibility introduces an entirely different interpretation of the January 22nd alignment event. Instead of being a passive comet passing in front of the Sun, 3I Atlas might have been deliberately orienting itself. The object could have been positioning its surface toward the Sun while adjusting its motion relative to Earth. If that interpretation were correct, then the anti-tail pointing toward the Sun might not simply be reflected sunlight or gas. Some analysts suggested it could represent a directed emission, possibly a transmission beam or an energy collection process using solar radiation. At the same time that Hubble captured these unusual structures, TESS, the one spacecraft capable of recording the entire sequence continuously, suddenly stopped delivering clear data. Officially, the explanation remains a temporary technical issue, but the timing of that interruption has become one of the most debated details surrounding the event. Because if the object truly deployed 3 equally spaced jets during that alignment, then the maneuver might not have been accidental at all. It could have been a controlled adjustment. And if 3I Atlas was adjusting its trajectory, that raises a far more important question. Was it continuing its path out of the solar system as originally reported, or was it preparing to change direction? The answer to that question lies hidden inside another detail from the data release, a subtle difference in brightness between the 3 jets that suggests something unexpected about the condition of the object itself. When Professor Avi Loeb described the 3 jets observed in the Hubble data, he included one detail that initially seemed minor but later became extremely important. 2 of the jets appeared bright and clearly visible in the images. The third one, however, was noticeably weaker. At first, this might seem like a simple observational effect. Perhaps the faint jet was partially hidden by the viewing angle or obscured by dust, but when scientists considered the geometry of the alignment, that explanation became less convincing. During the January 22nd event, Earth, the Sun, and 3I Atlas were positioned in a nearly straight line. With that configuration, all 3 jets should have been visible if they were equally active. The fact that one appeared faint suggested something else. It may not have been producing as much energy. In other words, one of the 3 jets might have been partially inactive or damaged. If 3I Atlas truly uses a triangular configuration of thrusters or vents, losing power in one of them would create instability. The object would begin to wobble slightly while trying to maintain balance. Interestingly, astronomers had already observed a subtle oscillation in the object's motion weeks earlier during observations made in December. At the time, that wobble was attributed to irregular rotation typical of comets. But if the object actually possesses a structured propulsion system, the oscillation might represent something different, a vehicle attempting to stabilize itself despite a weakened thruster. This interpretation introduces a surprising possibility. Instead of an unstoppable, perfectly functioning craft, 3I Atlas might actually be damaged. Something could have happened to it long before it entered our solar system. Perhaps the object spent thousands or even millions of years traveling through interstellar space. Over that immense journey, systems could degrade or fail. Or perhaps it encountered something unexpected near the outer edge of our system before being detected by our telescopes. Whatever the cause, the imbalance between the jets suggests the object may not be operating at full capacity. And that possibility may explain the unusual maneuver performed during the solar alignment. If the object needed additional energy or needed to correct its trajectory, positioning itself between Earth and the Sun could have allowed it to harvest solar radiation or perform a controlled maneuver using sunlight as an energy source. Even a damaged system might still function well enough to perform such adjustments. But the implications go beyond engineering. If 3I Atlas is not a natural comet, and if it is attempting to stabilize its movement while heading toward the outer solar system, then its destination becomes extremely important. Current trajectory calculations suggest that its new path could bring it closer to Jupiter, the largest planet in our system. Jupiter's enormous gravitational field and powerful magnetosphere make it a unique environment. Some scientists speculate that any advanced probe traveling through a solar system might use a planet like Jupiter as a staging point, energy source, or observation platform. That idea remains speculative, but it is one reason why researchers have recently proposed new observation networks capable of tracking interstellar objects more closely. Professor Loeb himself has suggested building advanced telescope arrays and interceptor missions capable of studying such visitors directly. For now, 3I Atlas continues moving deeper into the solar system. Whether it is a natural comet with unusual behavior or something far more complex remains an open question, but the evidence collected during the January 22nd alignment, the precise geometry of the jets, the mysterious data gaps, and the imbalance between the thrusters ensures that scientists will continue studying this object carefully, because the next stage of its journey may reveal whether we are observing an ordinary cosmic visitor or something far more extraordinary drifting through our celestial neighborhood, and what happens when it reaches the region near Jupiter may answer the biggest question of all. If the earlier observations already sounded strange, the next development makes the situation even more difficult to ignore. When scientists began recalculating the trajectory of 3I Atlas after the January 22nd maneuver, they noticed something subtle but important. The object was no longer following the exact hyperbolic path that had originally been predicted. A hyperbolic trajectory normally means an object enters the solar system once and then leaves forever, flung back into interstellar space by gravity, but the new calculations suggested a small change in velocity at delta v that could not easily be explained by natural forces alone. In orbital mechanics, even a tiny change in velocity can alter an object's entire future path. If the three jets observed by Hubble were indeed firing in controlled bursts, then they could have applied the equivalent of a braking maneuver. Not enough to stop the object instantly. Of course, space doesn't work that way, but enough to bend its path. Instead of leaving directly, 3I Atlas may now be entering a stretched, highly eccentric orbit that carries it toward the outer planets before looping back again. And that is where Jupiter enters the story. Jupiter is not just another planet. It dominates the outer solar system with immense gravity and an enormous magnetic field. Any object approaching that region can use the planet's mass for gravitational adjustments, a technique spacecraft engineers call a gravity assist. If 3I Atlas is capable of controlled maneuvers, Jupiter would be the most logical place to stabilize its orbit and conserve energy. This possibility explains why several researchers are suddenly discussing new observation networks and even potential interceptor missions. Officially, these proposals are described as scientific tools designed to study interstellar visitors. But the urgency behind them suggests that scientists want to be ready if another object like this appears, or if this one behaves in ways we still don't understand. And that leads directly to another discovery hidden inside the data release, one that raised even more questions about what exactly happened during that January alignment. Buried within the archive released by NASA and the European Space Agency were references to several files that were not actually included in the public dataset. The files themselves were missing, but their names still appeared in the index. At first glance, this might seem like a simple archival mistake, but the names of those files tell an intriguing story. One file was labeled Spectrogram Anomaly, another carried the title High Frequency Trajectory Correction, a third entry mentioned Delta V Unaccounted. Each of these phrases points towards something unusual occurring during the observation period. In scientific language, Delta V Unaccounted suggests that an object changed its speed in a way that cannot be explained by gravitational forces alone. But the file name that truly captured attention was something else entirely. Target Lock Confirmation. Those three words sparked immediate debate among analysts reviewing the data index. In standard astronomical terminology, target lock is usually associated with tracking systems that follow moving objects. It does not typically appear in discussions of natural comets. Of course, the file could refer to a telescope locking onto its target for stable observation. That is the most straightforward explanation. However, when placed alongside the other file names and the unusual jet geometry, the phrase invites more questions. Was the telescope confirming its tracking lock on the object, or was the object itself somehow interacting with observational instruments? No official clarification has been provided about the missing files, and the agencies involved have not commented publicly on why they were absent from the archive. For now, the safest interpretation remains that the names refer to technical procedures within the observation process. Still, when combined with the precise 120-degree jet pattern, the temporary TESS data interruption, and the slight trajectory change after the alignment event, the missing files add another layer of mystery to the story of 3I Atlas. And that mystery leads us to the final stage of this unfolding investigation: what might happen next as the object continues its journey deeper into the outer solar system. All of these details, the unusual alignment, the symmetrical jets, the missing data frames, and the subtle trajectory change converge on a single question that scientists are now asking quietly behind the scenes. What happens next? Current projections suggest that 3I Atlas will continue moving outward toward the region dominated by Jupiter's gravity. The giant planet acts like a gatekeeper to the outer solar system, influencing the paths of countless asteroids and comets that pass through its domain. If the object truly experienced even a small course correction during the January 22nd event, Jupiter's gravity could amplify that change dramatically. Some astronomers believe the encounter will simply send the object back out toward deep space. Others think it could settle into a long, looping orbit that occasionally brings it back toward the inner solar system over extremely long timescales. For now, the scientific community is watching carefully, collecting every possible observation before the object grows too distant for detailed study. What makes this moment so fascinating is that it highlights how much we still have to learn about interstellar visitors. Only in recent years have astronomers begun detecting objects entering our solar system from other stars. Each one carries clues about distant planetary systems and the processes that shape them. 3I Atlas may ultimately turn out to be an unusual but entirely natural comet, or it may reveal properties we have not yet encountered in cosmic debris traveling between the stars. Either way, the observations collected during this event will influence how scientists search for and analyze similar objects in the future. Because every time we discover something new drifting through our cosmic neighborhood, it reminds us of a simple truth: the universe is far larger, far stranger, and far more mysterious than we once imagined. And if you're fascinated by mysteries like this, the kind that sit quietly in scientific data waiting to be uncovered, make sure you subscribe to the channel, leave your thoughts in the comments, and join us in the next video as we continue exploring the most astonishing secrets hidden across the universe.